In today's lecture, we will study about nomenclature of alkane, classification of carbon atoms, alkyl group, and sources of alkanes. First of all, we will study about hydrocarbon. Hydrocarbon is a compound composed of only carbon and hydrogen. For example, methane, ethane, propane, benzene, etc. Types of hydrocarbon. Saturated hydrocarbons, those hydrocarbons which contain only carbon-carbon single bonds are called saturated hydrocarbons. For example, methane, ethane, propane, that is, all alkane are saturated hydrocarbon. Unsaturated hydrocarbon, a hydrocarbon that contain one or more carbon-carbon double bond, triple bond, or benzene ring is classified as unsaturated hydrocarbon. For example, ethene, ethine, and benzene. Classification of carbon and hydrogen atom. A carbon atom which is bonded to one another carbon atom is called primary, which is bonded to two other carbon atom is called secondary, and a carbon atom which is bonded to three other carbon atom is called tertiary carbon atom. A quaternary carbon atom is that carbon which is attached to four other carbon atom as shown in figure. Hydrogen present on primary carbon is called primary hydrogen. Hydrogen present on secondary carbon is called secondary hydrogen. And hydrogen present on tertiary carbon is called tertiary hydrogen. Now, what are alkanes? Alkane are saturated hydrocarbon, that is, they contain only carbon-carbon single bond. For example, methane, ethane, propane. Now, we know that alkane are also known as aliphatic hydrocarbon. Why they are called aliphatic hydrocarbon? Because the physical property of higher member of the alkane family resemble to those of long chain carbon molecule found in animal fats and plant oil. Also, Greek letter alipher means fat or oil. They alkane are also known as paraffins because in Latin param means little and affinis means affinity. So these have very low reactivity towards most of chemical reagent, or in other words they are relatively inert towards most of chemical reagent. That's why these are called as paraffins. The general formula of alkane is CnH2n plus 2, where N is 1 2 3 so on. Now, based on the structure, alkane are of two types. Number one, straight chain alkane. Alkane in which no carbon atom is attached to more than two carbon atom are called straight chain alkane. For example, butane, hexane. Branch chain alkane, alkane in which at least one carbon is linked to three or four other carbon atom are called branch chain alkane. For example, isobutane and tertiary butane. In the structure shown below, we see that propane, which is a straight chain alkane, have only primary and secondary carbon, while 2-methyl propane and 2,2,4 trimethyl pentane have tertiary and quaternary carbon. We can also define straight chain and branch chain in terms of type of carbon atoms. That is, a carbon chain or alkane having only primary and secondary carbon atom is called straight chain alkane, while a alkane which contain at least one tertiary or quaternary carbon atom is called branch chain alkane. Now we will study about alkyl group. Alkyl group is derived from the alkane. To derive alkane from alkyl group, we will remove one hydrogen. For example, CH4, which is an alkane, if we remove an hydrogen from CH4, the resultant is CH3. This CH3 is an alkyl group. In particularly, it is called methyl. That is, what is alkyl group? Substituent group derived from an alkane by the removal of hydrogen atom is called an alkyl group, and it is commonly represented by symbol R. We name alkyl group by dropping the "ane" from the name of parent alkane and add the suffix YL. As shown in the figure, methyl from methane. If we remove one hydrogen from ethane, the group will become CH2, CH3, and the ethane, after dropping ane and adding YL suffix, will changes into eth plus il ethyl. Similarly, from propane we obtain propyl, from butane we obtain butyl, from secondary butane we obtain secondary butyl, tertiary butane we obtain tertiary butyl group. All these are alkyl group. The general formula of alkyl group is CnH21 plus 1, where N is equal to 1, 2, 3, so on. Now we will study nomenclature of alkane. Name of simple alkane, that is straight chain alkane, is consist of only two parts, that is word root and primary suffix. Word root tells about number of carbon atom present in the chain, and primary suffix used in case of alkane is "ane", which is used for carbon carbon single bond. Hence, IUPAC name of alkane is consist of word root plus primary suffix. Some word roots for different number of carbon atom present in chain are: if number of carbon atom are 1, word root is meth. For carbon 2, word root is eth. For 3 carbon, prop. 4 but. 5 pent. 6 hex. 7 hept. 8 oct. 9 non. If number of carbon atom is 10, word root is dec. Similarly, for 11, 12, 13, word root is undec, dudec, tridec, so on. For now, we will see some example for nomenclature of simple alkane. Example number 1, CH3, CH2, CH2, CH3. This molecule have 4 carbon atom, so its word root is but, and primary suffix for carbon carbon single bond is "ane", so the name of compound is butane. Similarly, for a molecule having 6 carbon atoms, word root is hex. Primary suffix for alkane or carbon carbon single bond is "ane", so the name of compound is hexane. Now we will study about nomenclature of branched alkane. The IUPAC name of branched chain alkane are derived according to following rule. Rule number 1, longest chain rule. According to this rule, we have to select longest chain of carbon atom in the molecule, which is known as parent chain, while all remaining carbon atom which are not included in parent chain are taken as substituent. For example, In figure, we will see molecule 1 have its longest chain of 5 carbon atom shown in dotted bracket, and it will have CS3 group as a substituent. So its name is 3-methyl hexane. Similarly, in second molecule, the longest chain contains 7 carbon atom, hence it is named as a derivative of heptane having two substituent methyl on left and ethyl CH2CH3 on right hand side. Rule number 2, rule for larger number of side chain. According to this rule, if two different chain of equal length are possible, we select the chain with larger number of side chain. For example, as shown in the figure on left hand side, the compound is named as hexane with two alkyl substituent. One substituent is on carbon number 2 and other is on carbon number 3. One substituent is methyl and other is ethyl. But on right hand side, if we select the chain in such a way that it will has only one substituent and third carbon atom, then this is the wrong way, because according to the rule of larger number of side chain, the structure shown on left hand side have correct way of numbering the side chain. Rule number 3, lowest number or locant rule. According to this rule, numbering of carbon atom in parent chain is done from that end which gives lowest number to carbon atom carrying the substituent. As we see in structure 1a, the numbering of chain is done from left hand side so that the substituent carbon having substituent methyl, that is CS3 group, will have number 3. But if we done the numbering of same molecule from right hand side as shown in figure 1b, then the same substituent, that is methyl group, will have numbering 4. So the correct method of numbering is that we have to start numbering from left hand side, because on doing numbering from left hand side the substituent will get number 3, while if we do numbering from right hand side the substituent will get number 4. So according to lowest number or locant rule, the numbering done from left hand side is the correct way of numbering, because in this way the locant is lowest or numbering of carbon atom bearing the substituent is lowest. Next rule is the lowest set of locant rule. When two or more substituents are present, carbon atoms of parent chain are numbered in such a way that the set of locant is the lowest. This is called lowest set of locant rule. For example, in example number first, the numbering is done from right hand side Then the substituent are present on carbon number 4 and carbon number 5. So set of locant is 4 5. But if the numbering is done from the carbon on top as shown in left hand side, then the substituent will get the number 3 and 4. That is set of locant is 3 4. As 3 4 set of locant is lowest than set of locant 4 5. So the numbering done on the molecule as shown on left hand side is the right way of numbering the molecule. Similarly, in next molecule, if numbering is done from right hand side, then the substituent present on 2 4 carbon atom. So set of locant is 2 4 4 because at carbon number 4 there are two substituents. So set of locant is 2 4 4. But if numbering is done from left hand side, then set of locant is 2 2 4, which is the lowest set of locants. Hence numbering is correct, which is shown in left hand side molecule. Rule number 5, name of complex molecule. Name of the substituent is written as a prefix to the parent chain name and indicating its position by writing before it the number of carbon atom on which the substituent present. The number is separated by a hyphen from rest of the name. For example, for the given compound, the numbering is done from left hand side and the substituent is present on carbon number 2 having 4 carbon atom. For 4 carbon atom, word root is but and suffix is "ane". Since substituent is present on second carbon atom, it is written as prefix before parent name as 2-methyl and 2 is separated from rest of the name by a hyphen symbol. Similarly, on second molecule which has 6 carbon atom, substituent is present on carbon number 3. The substituent present on carbon number 3 is ethyl. Hence, the name of molecule is 3-ethyl hexane. Rule number 6, alphabetical order of simple substituents. When two or more simple substituents are present on parent chain, each group prefixed by its locant is arranged in alphabetical order before the name of parent chain. For example, in the given example in the slide on left hand side, the parent chain will contain 6 carbon atom and numbering is start from left hand side and there will present two substituent methyl at position 2, ethyl at position 3. But alphabetically, ethyl is prefixed before methyl group because alphabetically E comes first before M. Hence, the name of molecule is 3-ethyl 2-methyl hexane. Similarly, in the molecule on right hand side, the parent chain have 7 carbon atom with the numbering represented in picture in such a way that the carbon number 3 have methyl group, carbon number 4 have ethyl group, but alphabetically ethyl group is coming first then methyl. Hence the name of compound is 4-ethyl 3-methyl heptane. Rule number 7. Numbering of different substituent at equivalent position. That is, when these two different substituents are present in the carbon chain in such a way that we do the numbering of parent chain either from one side or from other side, the chain length do not alter and the substituent will comes on same position. For example, as shown in figure, if in the given molecule we done the numbering from left hand side or right hand side, the chain will contain, the longest chain will have 7 carbon atom in it and the substituent will present on 3 and 5 position in both way of numbering. But the substituent present on 3 and 5 position are different. That is, one substituent is methyl and other is ethyl. So to decide which substituent is present on 3 and which substituent is present on 5. In such case, when two different substituent present on equivalent position, numbering in done in such a way that the alphabetically order comes first. That is, the substituent which comes first in alphabetical order get the lowest number. So in this example, as ethyl group comes alphabetically first then methyl, so ethyl group will get number 3 while propyl group will get methyl group will get number 5. Naming same substituent at different position. When same substituent present more than once on a parent chain at different position, the locant of each substituent is separated by commas and suitable numeral prefixes, like if the same substituent present 2 times, it is written 2 times, then prefix is di. Tri for 3, tetra for 4 are attached to the name of substituent. For example, in example number 1, there are 2 methyl group present on carbon number 2. So the name of compound is 2,2-dimethyl propane. It is to be noted that locant 2,2 is written twice and the prefix di is used before the substituent name methyl. Similarly, in example number 2, methyl group is present on carbon number 2 and 4. Since at carbon number 2 there are 2 methyl group, hence the name of the compound is 2,2,4 trimethyl pentane. Similarly, in the next compound which contain 8 carbon atom, the methyl substituent is present on carbon number 2, 5 and 6. So name of compound is 2,5,6 trimethyl octane. In next example, having 5 carbon atom in parent chain have 2 ethyl substituent on carbon number 3. So the name of compound is 3,3-diethyl pentane. Similarly, in next example, having parent chain of 6 carbon atom, there are present ethyl group methyl group at position number 2, 3 and ethyl group at position number 3. Hence, the compound is named as 3-ethyl 2,2,3 trimethyl hexane. Ethyl group is written before methyl group because in deciding the alphabetical order of the substituent, the prefixes like di, tri are not included. So, it is to be noted that in trimethyl, it is M of methyl word which is used to decide alphabetical order. It is not tri word which is used to decide alphabetical order. Hence, ethyl is written first, then methyl group. So, the name of compound is 3-ethyl 2,2,3 trimethyl hexane. Similarly, in next example, having 6 carbon atom and substituent present at position number 2, position number 3 and position number 5. At 2 carbon number, there are 2 methyl group. On carbon number 3, ethyl group, and carbon number 5, again methyl group. So there are 3 methyl group. So the word tri is used because the same substituent occur 3 times. While writing the full name of the compound, we will again write ethyl substituent first, then we written methyl, because here also it is noted again that in deciding the alphabetical order the prefix tri is not used. So ethyl group is written before methyl group. Hence, name of compound is 3-ethyl 2,2,5 trimethyl hexane. Rule number 9 for naming of branched alkane is naming of complex substituent. In case the substituent on parent chain is complex, it is named as a substituted alkyl group by separately numbering the carbon atom of this group attached to parent chain as 1. Name of the complex is substituent is always enclosed in bracket to avoid confusion with number of parent chain. Number 1, if chain length of two substituent is of equal length, then the complex substituent with larger number of alkyl group forms a part of longest carbon chain while other one is treated as a complex substituent. To elaborate this rule, let's take the example. As in example, we see that the numbering is done from the methyl carbon present on the below side, and it have 10 carbon atoms up to another methyl group on left hand side. In numbering, in doing the numbering in such a way that we look that at carbon number 5 there will present a substituent. This substituent have 4 carbon atom with a ethyl group on carbon number 2. If numbering is done from right hand side, then the longest chain also have 10 carbon atom. But in that case, the substituent will be the carbon shown on the lower side of the molecule, and this substituent have two side chain at carbon number 3 due to 2 methyl group at carbon number 3. While in doing the numbering from lower carbon, it is clearly seen that the parent chain have more number of substituent, 2 at number carbon number 3, 1 at carbon number 5. So this is the correct way of numbering. Hence the name of compound is 5,2-ethyl butyl 3,3-dimethyl decane. While deciding the alphabetical order of various substituents, the name of complex substituent is considered to begin with first letter of its complete name. For example, in the given example, having 12 carbon 13 carbon atom in the parent chain, the word root for it is tri-dec and suffix is "ane", so parent chain name is tridecane. Now the substituent will present at carbon number 5, carbon number 7. At carbon number 5, the substituent is ethyl, while at carbon number 7, there is a complex substituent. So we have to done naming of this complex substituent also. The carbon attached to carbon number 7 is numbered again as number 1, and the substituent have 4 carbon in the longest chain as shown in figure, with 2 methyl group present at position number 1 and position number 2 of the substituent. So the name of the substituent at carbon number 7 is written in a bracket at position number 7, then a hyphen, and the name of complex is written in bracket to avoid confusion. Since parent chain of the complex substituent have 4 carbon atom, so it has name butyl, and having two substituent at carbon number 1 and 2, so complete name of complex substituent is 1,2-dimethyl butyl. Now you note in this example, dimethyl butyl is written first, followed by other substituent at position number 5, which is ethyl. So it is to be noted that in case of complex substituent, the whole name of the substituent, whether it include the word di, tri, tetra, is used to determine the alphabetical order of the substituent. That's why the substituent present at carbon number 7 is written first in the name of that compound, and the name of compound is 7,1,2-dimethyl butyl 5-ethyl tridecane. Rule number 3: when the names of two or more substituent are composed of identical words, priority of citation is given to that substituent which has lowest locant at the first cited point of difference within the complex substituent. For example, as shown below, the given molecule has parent chain of 13 carbon atom in which numbering is start from right hand side, and this parent chain have two substituent at carbon number 6 and carbon number 8. Both the substituent are complex substituent and both complex substituent have same number of carbon atom in their parent chain, that is 4 carbon in the parent chain of both substituent having same substitute at 1 carbon and carbon number 2. The substituent in complex substituent is methyl group. So the name of one complex substituent is 1 methyl butyl and other substituent is 2 methyl butyl. So numbering in this whole molecule is done in such a way that 1 methyl butyl complex substituent have lower numbering than 2 methyl butyl. So the numbering is done from right hand side because when numbering is done from right hand side, 1 methyl butyl will get number 6 while 2 methyl butyl substituent has comes on carbon number 8. If the numbering is done from left hand side, then 1 methyl butyl have number 8 and 2 methyl butyl have number 6, which is not according to the this rule. So to follow the rule, we have to do numbering from right hand side so that 1 methyl butyl will have get lowest locant number while 2 methyl butyl get higher locant number in comparison to 1 methyl butyl. Hence the name of compound is 6 1 methyl butyl 8 2 methyl butyl tridecane. Next topic of the video is sources of alkane. There are three major sources of alkane throughout the world, which are natural gas, petroleum, and coal. Natural gas consists of approximately 90 to 95% of methane, 5 to 10% ethane, and a mixture of other relatively low boiling alkane like propane, butane, and 2-methyl propane. Next source is petroleum. Petroleum is a thick viscous liquid mixture of literally thousands of compounds. Most of them are hydrocarbon formed by decomposition of marine plants and animal. Petroleum in form of petrol, diesel, kerosene, etc. is used in various utility in our daily lives to run automobiles, aeroplanes, and in form of kerosene oil it is also used to generate energy. Coal. How can we say that coal is a source of alkane or raw material for large number of organic compound? To use it, we take the example of synthesis gas. Synthesis gas is a mixture of carbon monoxide and hydrogen in varying proportion depending on means by which it is manufactured. Synthesis gas is prepared by passing steam over coal. Coal react with steam to form CO plus H2, and this is the composition of synthesis gas. Also note that methane is also a principal constituent of Mars gas, which is produced by anaerobic fermentation of cellulose. Some plants wax also have alkane. For example, some pine trees or wood turpentine contain N-heptane and cabbage leaf contain N-nonacosane. To test your knowledge, you try to solve the question given is slide. Question number 1. Define alkyl group with example. Write their journal formula. Question number 2. Give two examples each for branch chain and straight chain alkane. Question number 3. Why alkane are called paraffins? Question number 4. Why alkanes are known as aliphatic hydrocarbons? Question number 5. Name the major sources of alkane. Question number 6. Give IUPAC names of following alkane. Question number 7. What is wrong with following names? Draw their structure and give correct names. Thank you for watching this video.